Okay. Hello everyone. I am Indrajyoti Gaine and I am a PhD student from Department of Mathematics and Statistics IIT Kanpur. And presently I am a PMRF fellow and I have cleared my CSR net with the rank 108. Okay. So in the last class we are discussing about relation and function. So from the beginning of this lecture series, we have defined what is our relation, and from relation, which kind of relation we can say a function and which kind of relations are not say a function. So we have defined which are we can say functions, and how we can define a function and how we can classify that it is only relation or which is not a function. And after that we have seen how to draw a graph of the function, how to draw the graph of a function. And also we have seen some beautiful examples of functions like greatest integer function, signum function, modulus function, and rational functions, and many other things. So in the today's lecture we will start with a few more example of function. So let us start with the example. With the example that find the domain and range of the following function. Okay. Find the domain and range of the following function. Okay. So how can I avoid the functions? Functions are given by one is fx equals to mod x, and another one is fx equals to root over 9 minus x square. Okay. So in the first case, our f is a function which is defined by fx equals to mod x. Now, every real number can be put inside mod x. So the domain of the function, domain of the function f must be R. This must be R because all x belongs to R. We can have mod x, just a positive value of every real number. Like if the real number is positive, then we will take the real number itself, and if the real number is negative, then we will take minus sign of it, that number. So the positive part of the number. So every real number can be put inside this mod x. So that's why we can say the domain of the function is real number. But what about the range of the function? So we have taken the range of the function to be mod x. So mod x is always greater than or equal to 0. So mod x is always greater than or equal to 0. Therefore, this implies, since this happened, this implies range of the function f, this is nothing but the interval 0 to infinity, or one can say r greater or equal to 0. These two notations are same because this is saying that real numbers which are greater than or equal to 0. So range of the function is r0. Therefore, this function is a function f from r to r greater or equal to 0. Okay, domain is r and range is r greater or equal to 0. Now, what about the second function? The second function is given as fx equals to root over 9 minus x square. Okay. Now check one thing, that we cannot take square root of some negative value. That is, we cannot take square root of -1 or square root of -2. Yes, this has some different notation. We usually say that minus or square root of -1 equals to the I, and which is the representation of the complex numbers. So here we are not dealing with complex numbers, so we will not allow this kind of scenario in our case. Okay, so in our case we will not allow this kind of scenario. Okay, so we will only allow uh, square root of some positive number, square root of some positive number where x greater equal to 0. We will only allow this kind of thing. So considering that thing, what is the case here? So we must need this 9 minus x square part. This should be greater equal to 0, right? To get some well-defined value, we must need this part should be greater equal to 0. So what this implies? This implies 9 greater equals to x square. This implies x less than x should be either less than equals to 3 or x should be greater equals to -3. Okay, am I right? Yeah, in both cases we can say if x3 -3, x greater equal to -3, then x square would be less than equals to minus. Yeah. So either x greater equal to 3 or less than equal to 3 or greater equals to -3. Or else we can do in some different part, like we can break it, like 9 minus x square, this greater equal to 0. This implies 3 minus x, 3 plus x, both greater than equal to 0. Now this implies either 3 minus x greater equal to 0 and 3 plus x greater equal to 0, or 3 minus x less than equal to 0 and 3 plus x less than equal to 0. Okay, from here what we can see? We can see that in the first case we get x, this should be less than equal to 3 and x should be greater equal to -3. Or in the second case what we get? X should be greater equal to 3 and x less than equal to -3. So depending on the domain, whatever domain we choose, we will get a range. So we are choosing this domain. So okay, let us check with this domain once. If I take some x greater than equal to 3, okay, then x square minus 9, this should this be greater than 0? Okay. Okay, if I take x greater than equal to 3, then it will not be greater than 0. So we can take this part. We can't take this part. So only part left, the upper part. Okay. So what is the domain of this function? Okay. The domain of the function f is -3 to 3. Okay. And what about the range? Range of f. So whenever x belongs to this range, if x belongs to this range, then what will be the values of f of x? So check this by some different way. This thing implies x square This is less than equals to 9 and greater than equals to, okay, this should be less than equals to 9, right? This implies x square minus 9. What happened? Correct or not? I'm doing something wrong. Okay, if I take this thing domain of the function like this, in this case I'm doing something wrong, right? This is less than 3, x square will be less than 9. This thing happening, then why it is? We are dealing with 9 minus x square, right? Okay, we are dealing with 9 minus x square, which implies 9 minus x square. This is greater or equal to 0. This implies square root of 9 minus x square is greater or equal to 0. This thing means f of x is greater or equal to 0. So we can say that fx equals to fx should be in a subset of 0 to infinity, or we can say r greater or equal to 0. That is, we can say f is again a function from minus 3 to 3 to r greater or equal to 0. Okay. So thus we can define a domain and a range of the given function. So let us discuss a good example from JEE Main. Then we can clearly understand which type of question they ask in the exams, so that you can deal with those questions in the exam. So the question is, find the domain of the function fx equals to 1 by root over box x square minus 3 box x minus 10. But what is the box x? Box x stands for the greatest integer, the greatest integer less than or equal to x. Okay, so greatest integer less than or equal to x. What is the meaning? The meaning is, we have discussed the greatest integer function in the last class. So this is the greatest integer function. So whatever we have discussed, the greatest integer function in the last class, this is that function. Greatest integer. So if you observe clearly that this function fx is a combination of another function, which is the greatest integer function, right? Okay. So how to deal with this kind of question? So we need to find the domain of the function. So how can I find the domain of the function? So whatever we have told in the last example, that whenever we see something inside the square root, and we are not dealing with some complex number, so we must take this. We must take this condition, that root over x, whatever is inside the root over square root, that should be some number which is greater than or equal to 0. So in this case, to find the range of this domain of this function, we must take that we must need the condition box x square minus 3 box x minus 10. This should be greater than or equal to 0. Okay. Now, if I factorize this thing, now consider this box x equals to y. Put y equals to this box x. Then how we can write this expression? We can write this expression like y square minus 3y minus 10 will be greater than or equal to 0. Now it can be factorized more like y minus 5 y plus 2. This should be greater than or equal to 0. Right? So from here, what we can say, that either y belongs to 5 to infinity, or y belongs to minus infinity to minus 2. Okay. So where y belongs to, either in the interval minus 5 to infinity, or in the interval minus infinity to 2. How you can say? Clearly you can see that from here, when these terms are positive, product of two number is positive whenever both are positive. So we must need y minus 5 greater than or equal to 0 and y plus 2 greater than or equal to 0. Now this thing implies y greater than or equals to 5, and this thing implies y greater than or equals to minus 2. Okay, no. It should be less than or equal to 0 or greater than or equal to 0. Okay. Okay. So these two conditions together implies these two conditions. Right? Again, one can say that this expression is greater than or equal to 0 whenever y minus 5 this is less than or equal to 0 and y plus 2 this is less than or equal to 0. Now this implies y less than or equals to 5 and y less than or equals to minus 2. Okay. Y less than or equals to 5 and y less than or equals to minus 2. Okay. Now we got two different conditions. Condition 1, you can say this is condition 1, this is condition 2. Condition 2. This is condition 2. Okay. Now from condition 1, condition 2, you can clearly see that whenever y is greater than or equal to 5, it must be greater than or equal to minus 2. And whenever y is less than or minus 2, it must be less than or equal to plus 5. So this condition can be written as y greater than or equal to 5, and this is sufficient. And this condition can be written as y less than or equal to minus 2, and this is sufficient. Okay. Now combining these two conditions, we have written this condition. So y either 5 to infinity, y belongs to either 5 to infinity, or y belongs to minus infinity to minus 2. Okay. So thus we got this expression. We got this expression. Now from this, if we what okay, from this we have y belongs to either minus infinity to minus 2 union 5 to infinity. Okay, now we can replace this y by our greatest integer function. So this implies the greatest integer value of x should be lies inside minus infinity to minus 2 union 5 to infinity. Okay. Now, for which value of x we can get this range? So whenever x belongs to this boxes belongs to this range, so boxes belongs to this range means x belongs to x belongs to minus infinity to minus 2 union 6 to infinity. Why is this? Okay. Let us verify this statement. So we need this condition. We need to put this box x in this range. So for which kind of range we can get this thing? Let us check. So first check that whenever x less than minus 2, then what will be the box x? This is the greatest integer less than or equal to x. So greatest integer less than or equal to x should be minus 3. Okay, and boxes should be less than or equals to minus 3 whenever x equals to less than minus 2. When x less than minus 2, then box is less than or equal to minus 3, which is again less than minus 2. Okay, so this range is fine when x greater than 6 greater equal to 6, then box x should be greater equal to 6, which is greater than 5. So this range is obviously, for this range we can get the box x should be in this range. Now what about the middle portion? Whenever x greater equals to minus 2 and less than 6. In this case, box x should be greater than equals to minus 2 less than 5. Now you can clearly check that this range of box x is disjoint from this given range. Right? Here we have that box x should be inside the range minus infinity to minus 2 open interval. But here it is starting from the closed interval minus 2 to 5, which is complement to this interval. Which is complement to this interval. That's why we don't take this portion. We don't take this portion. That's why we took the portion x belongs to minus infinity to minus 2 union 6 to infinity. So thus we can find the domain of the given function. So if anyone asks that what is the domain of the given function, then the answers will be, so let us change the color, yellow, let's try. Okay, so domain is minus infinity to minus 2 union if to infinity. So thus we can find the domain of the function. Now do another example. Let us take the color. Okay. Next question is Okay. Another question. Okay. Here they are asking to find the range of the function fx. Find the range of the function fx equals to 4 sine inverse x square by x square plus 1. Okay, let us clearly write it. 4 sine inverse x square by x square plus 1. Okay, so we need to find the range of this function, and they have put in some option. So option A is the 0, 2 pi, close interval 0 to 2 pi. Option B is close interval 0 to 2 pi. Option C is 0 to pi, and option D is 0 to pi. Okay, so how can we do this problem? So this is the function. Obviously, the domain of this function is here. Domain of the function is the whole real number set. Okay, and we can see that first the function is doing like x square plus 1 by x square, then we are putting the sign inverse. Now this thing, you can see this must be greater than or equal to 0. This must be greater than or equal to 0 for any value of x. This for any positive or negative value of x, this must be greater than or equal to 0. So it is verified that this sine inverse x, this implies sine inverse x square by 1 plus x square. This should be greater than or equal to sine inverse 0, and which is nothing but 0. And if I multiply both sides by 4, then also it will be happen. So 4 sine inverse x square by 1 plus x square, this should be positive. This non-negative. At least that should be non-negative. Okay. Now what will be the upper range? Pi or 2 pi? That we will find. And after that, we will check that this inverse, that is the function, attending its boundary point or not. Okay. So for that, check one thing. Check that x square by 1 plus x square. This can be written as 1 plus x square minus 1 by 1 plus x square. This is like 1 minus 1 by 1 plus x square. This is clearly less than 1 for all value of x. If I put x equals to 0, then only the value will be 0, and otherwise for any real number, this should be strictly less than 1. This is not like less than equals to 1. This is strictly less than 1. Okay, so this implies sine inverse of x square by 1 plus x square, this should be less than sine inverse 1. And what is sine inverse 1? That is the pi by 2. Now if I multiply 4 with both sides, what we obtain? We obtain 4 sine inverse x square by 1 plus x square by x square plus x square into 4 into pi by 2, which implies 2 pi. Okay, so clearly we can see whatever is the function fx is given, this is greater or equal to 0 and strictly less than 2 pi. This is not attaining the value 2 pi. Okay, therefore the range of the function f this should be obviously closed 0, open 2 pi. Why open? Because the function is not attending the value 2 pi. That's why we will put the open interval. If it have already have attained the function value 2 pi, then we could write closed interval. So I think this much is clear. Oh, okay. Now let us discuss some new thing. Okay. So the next topic is algebra of functions. Algebra of real functions. To be precise, real. So from the part real functions, we can clearly can ask that is there any kind of other functions? So yes, there are other functions. Those are called complex valued functions or complex functions. So for that case, we are not doing anything right now, because for that thing we need to study the complex numbers first, and then we should study complex number addition, multiplication, and all these things, and then only we can go to that part. So we are not going that part. So algebra of real functions. So what we know by algebra of real function? Algebra of any function, any kind of algebra means there must be some addition, multiplication, subtraction, and division. So first, addition of two functions. Addition of two real functions. So how we can do that? So let we have two functions, f from x to y and g from x to y. So obviously, to have the addition, at least for satisfy the additivity condition, to satisfy uh, addition, we must need that two functions has same domain and range. Okay, or it can happen that if the two functions must need the same domain. The range can vary. Range is not mandatorily equal, but yes, the superset of the range. The superset of the range must be equal. That is the universal set. We have discussed about a universal set. So the universal set of the two ranges like fx and gx must be same. Okay, note the thing. So the range can be denoted like this: f of capital X. Capital X means the domain. So if d with the domain, we can denote range by f of d. This denote the function range. Okay. Okay. So we must need fx and g of x have same universal set. Okay. Then only we can have the addition of two real functions. So how we can define this addition of two real functions? So before that, we can make a like this, so that we not get confusion. Okay. So to get the function, Addition is another function defined like f plus g. This is a function from x to y defined as f plus g of x. This is equals to f of x plus g of x for all x belongs to capital X. So thus we can define addition of two functions. Okay. Now, how we can define the subtraction? So whenever we have defined the addition, it is very easy to define the subtraction. Subtraction of two real functions. How we can define this? So again, we have two functions. F from x to y and g from x to y, and f minus g is another function from x to y defined by f minus g of x equals to f of x minus g of x for all x belongs to capital X. Okay. Now, how we can define the multiplication? So, check one thing that for addition and subtraction, we just change the sign of, from the plus to minus, and else all the condition must be satisfied by the same two functions. Otherwise, we can't define the subtraction of two functions. We can't define subtraction of two functions. Okay. Now the third thing is multiplication of two functions. So multiplication can be two types. One scalar multiplication and another is multiplication of two real functions. So first check scalar multiplication with a function. So how can we define this? Let f from x to y is a function and lambda is a scalar number. Okay, then we define another function that is called a scalar multiplication with the function f, that is the function lambda f from x to y defined by lambda f of x. This is equal to lambda into f of x for all x belongs to capital X. Okay, and how we can define multiplication of two functions? Multiplication of two functions. So how we can define? Let us have that f and g be two function, f from x to y and g from x to y. Okay, in this case also the domain set must be same. Range set can be varied. In that case, it is not that much issue, but universal set may vary. But okay. But all this case, the domain set must be same. Okay. Okay, so how we can define this? If g, this is a function from x to y such that if g of x, this is equals to f of x into g of x for all x belongs to capital X. So for all x belongs to capital X, if g of x equals to fx into gx. So thus we can define multiplication of two real functions. Okay. Okay. And last, we have fourth algebraic property. It is division or quotient of two real functions. Quotient of two real function. So in this case, let y and g from x to y be two function, and in this case we need another extra condition that g of small x not equal to 0 for all small x belongs to capital X. Okay, then we can define the function f by g, which is from x to y, defined by f by g defined by f by g of x. This is equal to f of x by g of x for all x belongs to capital X. So clearly you can see why we need the condition gx not equal to 0 for all x. Because if for any x gx becomes 0, then for that x we can't define fx by gx. So to get quotient of two real functions, we must need which function is in the below. Then that function must not attain the value 0. Okay. So let us do one example so that this thing gets some clarification. So the example is, to write the question, read. Example is, let fx equals to x square, and gx equals to x plus 1. So clearly these two are real functions. Now find what about f plus g, fg, f by g, g by f, and f minus g. So we need to find all these things. 1, 2, 3, 4, 5. Okay. So check. Let us check. What about f plus g? So f plus g of x. This means fx plus gx. So what is our fx? This x square. What is our gx? That is x plus 1. So together this implies x square plus 2x plus 1. Now what about f minus g of x? That is equal to f of x minus g of x. This implies x square minus 2x plus 1. So together this implies x square minus 2x minus 1. Clear? Now what about if g of x? So if g of x means fx into gx, that is equals to x square into 2x plus 1. So that thing is nothing but 2 into x cube plus x square, right? What about f by gx? F by g of x. This is nothing but fx by gx. This implies x square by 2x plus 1. Fine. Now what about g by fx? That is then gx by fx. This is equals to 2x plus 1 by x square. Now check one thing, that in this case 2x plus 1 is not equal to 0, but here x square can be equal to 0 for x equal to 0. So we can't get this function. We cannot write this function. We can't write this function. Why? Because fx is getting 0 at x equals to 0. It may happen that the at 0 is not attending by the denominator function at the point 0. It may happen that the function is attaining 0 at the point 1, 2 or 5, anything anywhere else. But either it attaining 0, this function is ineligible to be a denominator. Okay. Okay. So let us take another example, which is very interesting example. You can see. Okay. Yeah. The question is red color question. The question is, if a function which is from r minus 0, 1 to r. So the domain is, we are excluding the points 0 and 1 from the set r, and the range set is the whole r. Okay. So we have defined, they have given a function which is defined on this domain, and range is in the domain r, and the function has some condition. If it is, so the function is like let if a function such that fx plus 1 by 1 minus x, this is equals to 1 plus x. Okay, for all x belongs to 1 minus 0, 1. Okay, then the question is, what is f of 2? Okay, so how can I check this? So here they have given the addition of the same function, but the domain is manipulated somehow. Here, yeah, obviously domain is this thing, but you can see that this function is a function from R to this function, this domain. This will never attain the function, this will never attain the point 0 and 1. So that's why they have defined these things. Okay. So what will be the value of f2, right? Okay. So put x equals to 2. This is obviously in the domain r minus 0 to 1. So we can put, so let us put the function there. So what do we get? F of 2 plus f of 1 by 1 minus 2. This is equals to this. This implies f of 2 plus f of minus 1. This is equals to 3. Now again put the value x equals to minus 1. Clearly that is also in the domain, right? So what we get? Minus 1 plus f of half. This is equals to 0. Clear? Now put x equals to half. So what do we get? F of half, f of 1 by 1 minus half is equals to 1 by 1 plus half. This is nothing but 3 by 2. So this gives f of half plus f of what? This should be 2. So 3 by 2. So thus we obtain 3 equations, right? Equation number 1, equation number 2, and equation number 3. This case to missed. Now we need to find the value of f2. So how we can find the value of f2? So we need to add 1 and 3 and subtract 2. So we can add the equation 1 with the equation 3 and subtract the equation 2. What we will get? That 2f of 2 equals to, the first equation gives us that 3 plus 3 by 2, 3 by 2 minus 0, right? Which is nothing but 9 by 2. So this implies f of 2 equals to 9 by 4. One, 4. So we don't know about the function explicitly, but using the addition and subtraction of functions and using the algebra of function, we can say we have clearly found the value of f of 2. And this kind of questions can be easily found in JEE main and advanced questions. So you can use the concept of function addition and function algebra functions to get the value of some at some point. Okay. Okay. So let us finish today's lecture with the last example. If a function f is equals to x square, then find f of 1.1 minus f of 1 is 1.1 minus 1. This implies 1 square minus 1 square by 1.1 minus 1. So from here, one can calculate the value of each element explicitly, that what will be the 1.1 whole square, and what will be the 1 squared, and we can subtract and divide all these things. But clearly we can apply a formula here. So the upper part is a square minus b square formula. So we can apply that 1 minus 1 minus 1, 1.1 plus 1 by 1 by, okay, what's the formula? 1.1 minus 1. Okay, now clearly we can cut these two parts, and we are ultimately left with 1.1 plus 1 equals to, which means 2.1. So the value of this is 2.1. So thus we can apply the formulas, and we can easily calculate the value of a given function, and using the given function we can find the value of particular point. And this kind of question clearly can be asked. And whenever a given function asks for the domain and range, for at first you first need to find the domain, because domain can be explicitly said as the domain of definition, that is when on which range the function is well defined. You must need to find where the function is well defined. This is not like the whole real number or like this, because we must need to find that in which range function can't be defined. Okay, so and depending upon the domain set, you can find the range set accordingly, because you whenever you found the domain set, then you can take the image of the elements of the domain set, and thus you can find the range set. So thus you can find the domain and range of any given function. So this all about the function relation and functions. So we have gone through the relation, and after that we went to the function, and we have seen some examples of where the function are not relation and where the relation are okay. We have seen the functions are all relations, but few relations are not functions. So this can be a very important point. And okay, so this kind of example can be asked in the exam. So from the next lecture we will start a new topic. So let's end this session here.